you need to make sure that you're not publicly disclosing anything that is considered IP before you file. Otherwise, it'll act against you as a public record or public knowledge. So for example, before submitting my master thesis, I filed this provisional patent application with the United States Patent Office.
Welcome back to the Clean Techies podcast, where we interview climate tech founders and VCs to discuss all things building and investing to solve the biggest challenge of our generation, climate change. Today we are joined by Anas Al Kassas, the founder and CEO of INOVUES, where they are helping solve heat loss for buildings. Their technology is essentially a retrofit solution to single-pane glass that can be achieved at scale. They are also partnering with other companies such as solar glass and tinting services to act as a platform for them to sell their technologies. The key things in this conversation that we discussed today are how their technology works, how he got started in the process of going through accelerators for them to get their initial round of funding. He also talked about the process of getting the IP licensed, how that worked and his experience and advice there, and how they are using creative financing models to remove the friction from buying for their buyers. Enjoy the episode. All right, welcome to the show, Anas. How are you doing today?
Thank you, Silas. I'm doing great. Thank you for having me.
Yeah, absolutely. Really excited to have you on. I think this is some pretty interesting technology. So before we get into that, let's just go into the beginning, a little bit about who you are and how did you get into this space?
Sure. So my name is Anas Al Kassas. I'm the founder, CEO of INOVUES, and the inventor behind the technology. My background is in architecture and facade engineering. I'm originally from Syria. I did my bachelor's degree in architecture in Damascus University, and then graduated, worked for a kind of regional facade fabricator instead of the traditional architectural office, and then went to Dubai, worked there for about 4 years with some of the best names kind of in the industry, in architecture and facade contracting, manufacturing, testing. So I got this multidisciplinary experience in architecture, facade engineering, and from there, I moved to Boston, did my master's degree in architecture at the Boston Architectural College, and worked for some interesting names in the architectural world, like Moshe Safdie Architects and Elkis Manfredi Architects, on projects all over the world. And within that period, I kind of started working on INOVUES as an idea for the first year, and then moved to Houston. Founded the company in 2017, and here we are.
Very good. So I'm kind of keen to get into this. So how I guess did you come up with the idea? Because you also mentioned at the beginning that you came up with the technology, so you invented it. So how does somebody go from being an architect to kind of tinkering with something and in developing a new technology? You know, people might be familiar with in the tech space. If people have an idea, they can just go like play around with a website or something or build something, right? It's not very technical. But this seems like something that's in kind of an invention. So could you talk about that process of how you came into this? Like what does it look like to tinker with that kind of thing? And then how did you end up getting the idea?
Yeah, sure. I mean, given my background in architecture, so architects are really great at being creative with problem solving. So a lot of times, you're facing in any project you're doing from the beginning, while it's on paper, you're facing a number of challenges that you're trying to resolve and come up with unique ideas and ways to do that. And in this case, I was intentionally looking for ideas that I can address and tackle from this multidisciplinary kind of point of view, where I have the technical knowledge about facade engineering, given that I work in this space, developing, building, testing, manufacturing these systems, and at the same time, being an architect, having this wide point of view about how buildings are constructed and designed and developed. So at one point I was looking for ideas where I can make a larger impact than just a one-off project or one-off prototype, and then you repeat the cycle again. I wanted to do something where it can be scalable, and it's a problem that has a wide impact nationally and internationally. So windows is something that I've known for, and facades really I've been interested in, especially kind of dynamic and advanced adaptive systems. My first serious attempt was actually my bachelor's degree project, and it won an international award. And that got me into the facade engineering world. And so that's kind of the first system. And it was a retrofit system, complete chance. And it was able to adapt to 108 conditions to filter air, light, and kind of all of the heat, cold and hot and cold, without having to really change anything. So it's like an adaptive system to whatever the condition is. So I was sitting in my apartment looking at the windows, and I started thinking, is there a way we can maybe transform these facades and windows to becoming smart, energy efficient without replacing anything? So that was kind of the start of the idea. I started looking, in the market, see if there's anything similar. And that's when I learned about the big energy efficiency problem with existing buildings, and that facades and windows are attributing about up to 40% of that problem. As architects, most of the focus we have is on new construction. So you're looking to build new buildings, but existing buildings represent like 98% of the built environment. And at the time, 10 years ago, or when you're in architecture school, little focus was given to existing buildings efficiency and performance, and kind of challenges and problems in the real world.
Hey there. Quick break to remind any founders or VCs listening, if you are looking for deal flow, seeking to raise funding, looking for partners to help service your needs, or perhaps you're looking for corporate investment partners, feel free to reach out to us through our Slack channel, which can be found in the description. Because we meet a lot of people in this space, we set aside time each week to make introductions to the various people that we encounter. This is something we do free of charge in order to help these incredible companies solving climate change to scale. Looking forward to hearing from you in the Slack channel. Interesting. So how exactly, what kind of resources does it require to play around with this? Are you able to kind of test out designs in some type of software to figure out, okay, how can we just take a piece of glass and infuse technology into it? Maybe it would be helpful if you give us an idea of what was already there, and you knew like what infrastructure was there to innovate within glass, and then how in the world do you get glass to have technology inside of it?
So one of the important things is that our technology is not around the glass itself. So the technology is glass agnostic, and adaptive to mostly any type of glass. The idea is, how can you integrate a new layer, a new piece of glass that has high performance, all the latest technologies into existing building facades without having to remove or replace the existing windows or glass systems, or have a very invasive process and costly process of doing so. So the technology is more around the system that enables that. And the idea, when as an architect, you can sketch and start to develop the entire solution from basic sketches and then rapid prototyping, using 3D printing. And I was able to use some of the resources that are at the Boston Architectural College when I was doing my master's degree, because it was around that topic, and the master thesis ended up becoming the early research report or book for this technology. So first year was just purely design thinking, trying to see what is currently available in terms of materials and components, and how other technologies like insulating glass technology work, and then how would you take that, reconstruct it in a different way where it enables what I'm trying to achieve. So you're looking at the kind of state of the art currently in different aspects, and then you're taking components and you're trying to reiterate until kind of you're solving all the challenges. So for the first year, it was pure system development, and there was no actual testing of the technology. It was just design thinking to be able to see, can this be done? You were pushing the boundaries on many fronts when it comes to facade engineering and system and facade systems and glazing systems. But the concept was very, very challenging at the beginning. So from there, after the first year, the system got to a point where it can be prototyped. And that was when I, went through the Cleantech Open Accelerator, to see, okay, how can we, because it's beyond now my capabilities to produce or fabricate such a system and go, put it through industry tests and see if it actually works. So I went through the accelerator and went through the Central Texas Angel Network fundraising process, and fortunately ended up winning the national award for the Clean Tech Open, which came in with a $50,000 check, non-dilutive funding, and at the same time got the kind of first angel investor from CTAN. So that money enabled me to fabricate the first prototype and put it through testing. Up until that moment, there was no guarantee that this technology is going to work. And after a year and a half of work and development and design and iterations, you put it through the testing in the real world. No matter how many simulations you've done and all the kind of interesting software applications you can use with FEA analysis and CFD and all of that, still, the real world kind of simulation of testing is different. So first couple of years was really challenging in terms of technology development.
So for those unfamiliar, I would like to ask two questions. So one is, what are the components that you're trying to solve? You mentioned temperature, you mentioned air quality. There's some things that you're trying to solve for. Let's first go there. What are those components that you had already been looking at to try to solve specifically for people unfamiliar with this design process?
Sure. So the primary use case for what we're doing is transforming single pane windows to double pane windows. And I don't know if you're familiar with this, but a lot of windows have a single layer of glass. And this is very energy inefficient because glass as a material is great. You can see through it, but in terms of heat transfer, it's one of the worst materials. So, you can lose a lot of heat when you have big difference in temperature between inside and outside. So if it's cold inside, cold outside, and you need to stay at around 70 degrees inside, then a lot of the energy being put into the space to keep it at a comfortable level is going out the window, literally. So transforming the single pane to double pane. So double pane windows, it's an invention, came in the mid last century. It's two panes of glass with an air gap in between. So you're kind of creating a sandwich out of it. And that became, kind of the standard in around the 80s, 1980s, 1985. But if you look at the current building stock, there's about 40% of all buildings still have single pane windows. And you need to replace them. And that's the problem. You can't, replacing them is very, very disruptive to the operations of the building. You need to vacate the perimeter spaces. And it's a very costly and long process. And you're throwing away an existing pane of glass that otherwise can live 1,000 years as a material.
Hey there. Are you building a climate tech business and looking for very specialized talent? Consider reaching out to our sponsors, NextWave Partners. NextWave are experts in talent acquisition, recruitment, and retention across the climate tech, renewables, and ESG spaces globally. So if your team is growing or you're looking to make a career change yourself, feel free to reach out to NextWave at next-wavepartners.com or reach out to one of their consultants directly via their LinkedIn page.
So the solution here is to try to build and utilize and upcycle what's currently existing instead of throwing it away, and add on top of it and create that sandwich in place, basically, out of the existing glass. This sandwich is typically this IGU insulating glass unit is built in a factory. So now you're replicating that on site, and you want to replicate it in a way that is scalable. So you're not doing this for one window, you're doing it over like a full building, maybe a high rise. So that's where the challenges come in. And all buildings have different shapes, different sizes, different characteristics. So you're trying to create a system that is scalable and adaptable and can work with all kinds of window systems and glazing systems and be able to perform well like a factory-made insulating glass unit, something that's kind of the unique aspect of it.
Got it. So the big issue of what you're trying to solve is really the energy efficiency, right? Because of the heat loss, because the air gap acts as essentially an insulation barrier to prevent more heat loss. I remember learning about that when I was young. We were building I was homeschooled growing up, and my dad was a builder. We built a new house when I was like 8, 9 years old, and I remember learning about the specific things around insulation because he's big on insulating our house so that we could heat it with a minimal amount of effort. But
Exactly.
so okay, so that's helpful. And then if we were to explain the technology to, your grandma, somebody who's maybe somebody who's very non-technical, if I want to make sure maybe I've got this right, but I'd like you to take a crack at it after I very badly take a stab, is you're taking existing glass from most likely single pane glass from buildings, and you're adding another piece of glass that's essentially acting as that second pane to create better insulation. And there's some other technologies involved as well that are there. Is that correct?
Yeah, you're adding another layer of glass with a separation between, creating sort of a thermos out of the, existing window. And that makes it more insulated. So lose little energy compared to the existing situation. It makes the space more comfortable, so you can sit near the window, work, sleep. It makes it much better in terms of the overall carbon footprint of the building. Energy emission, carbon emissions of the building too. And there's a number of technologies now when you're opening the world to adding another piece of glass, and you're looking at glass technology over the past decade or so. There's been a huge advancement in that area. So there are now advanced glass technologies, smart glass technologies. You can have transparent photovoltaic, solar windows that you can see through, that you can put on these high-rise buildings, and then you can turn building facades into micro power grids. You have dynamic tinting where you can change the tint of the window with a switch or a button on your phone, and control privacy, control solar heat gain. You have bird-friendly glass now. There are regulations in New York that mandating bird-friendly glass on all high-rises. There's a number of new technologies that are only now available for high-rise new construction, and now you can integrate these technologies into existing buildings in a cost-effective and non-disruptive way.
So you're taking your technology and then overlaying other technologies such as the tinting or
Yeah,
the solar technologies into this additional pane of glass. Is that correct?
exactly. So we've created more of, like, you want to think about it as a platform for these new glass products and solutions and technologies to be available or integrated into existing buildings.
Interesting. Okay. So
Yeah.
are you able to speak to us a little bit about the technology behind these like dynamic tinting mechanisms? Like, can you speak to that and how it works just at a very base level for us to understand?
Sure. So it's called, for dynamic tinting, there's a number of technologies. The simplest one, if you want to think about it, the transitional lenses. You go out and it becomes dark, and then you go inside. If it's dark, it becomes or bright, the opposite. So that's photochromic. Now there is thermochromic. So thermochromic, for example, if the glass is hot, it gets darker. So you put it on a building and the sun hits the glass. That means it's heating it up, and then it becomes darker to reduce the amount of heat gain that is going through the window. The more advanced kind or option of this technology is electrochromic. So electrochromic, you have kind of a sandwich, 2 layers of glass, and then a stack inside, basically an electrode and cathode, and then you run electricity in it, and then it turns that kind of layer or sandwich into a tinted glass, and you can control the level of tint. So you want it, 100% opaque, for example, for privacy, or you want it 25%. You can even connect it to sensors now on the building and have all the windows and facades be kind of connected to the building management system and tracks the weather conditions in real time. So you have expectations that it's going to be cloudy here, so you need to probably make it clearer. And then on the south facade, it's really hot, so you tint that area. Or in other cases, you have a nearby building, and the tenant or the occupant wants to maintain privacy at a certain time, so they can control it with their phone. There's an app. So there's a number of applications you can utilize, and this is just one technology. Now there is self-powered electrochromic that is being developed now, where you don't need the wires and the electricity. It's, it harvests the energy from the sun and then it activate the electrochromic. Uh, so there's a number of new exciting developments happening in the space.
Mm-hmm. Interesting. With at the risk of sounding very, very dumb, how exactly can they use electricity? Is there another layer or some type of film that goes on top of the glass for them to use to change that tint, or is it something that's like in the chemical makeup of the glass?
It's a film or a coating that is applied. So you have like a number of layers of very, very thin coatings, kind of nanomaterials applied on the surface of the
Mm,
glass, treated. And these layers, it's creating a stack and having this electrode and cathode. And, and you're
mm,
in the edge of you have bus bars at the edge of the glass, and then that's connected to, wires, and the wires are connected to
mm-hmm.
network. And then you can kind of control you need just 5 volts to activate and turn it from one state to another, something around that. And that's not our areas of specialty.
Yeah.
Working with these companies that are developing these technologies, we've come to learn all about these exciting systems.
Hey there, thanks for listening to this episode. If you made it this far, it's likely that you're enjoying the show, so I wanted to ask your help. If you're enjoying it, please give us a review on Apple Podcasts and share with somebody in the same industry who might find this interesting. And if you're interested in getting summaries of these episodes, go subscribe to our newsletter that comes out on LinkedIn and Substack. Links can be found in the description. Thanks for your help in growing the reach of this show. Yeah, that's quite interesting, though. I mean, either way, I think the really fascinating part here is that you are trying to create a platform technology that's physical, right? Like a physical platform
Yeah.
and the method to be able to apply these additional panes of glass to other buildings. So maybe really briefly, could we talk about how you do that, especially when you mentioned, of course, that you look at even your background, you've got all these different size pieces of glass. And I remember working for my dad in his cabinet shop growing up, we'd always, when we were, putting glass into some like cabinet doors or whatnot, we'd have to go call the hardware store and get the measurements. And like, how do you do this on scale?
Yes. So the first thing we wanted to make sure we nail that right is the adaptability of the system. So there are a number of tolerance gaps and tolerances incorporated into the development and design where you don't need the existing windows to be measured 100% accurately and like to a millimeter, for example, or to 1/16 of an inch. You don't need the windows to be 100% square because obviously you're dealing with windows that are like 10, 20, 30 years old. So there's a lot of irregularities there. So that's one of the things we've made sure the design from the get-go has that kind of capability and ability to adapt. What we do basically is we go to once we get a project, our people walk the building and kind of do a quick building survey, basically looking at the windows. They take measurements of a few window sizes, a few windows of each typical size. So when you're looking at a building, not every window has a unique size. You have maybe 3 or a few. And if you measure, 5 of each typical size, we have then formulas in-house where we can build on top of that and have a kind of an adaptable size that would work with everything else without having to go and measure everyone. So that's one of the aspects of how this could be scalable. From there, we've developed our own kind of installation tools that help guide this system when it's on site. So people that are trying to install it, they don't need any sort of heavy equipment or specialized tools or any sort of very deep, in-depth experience about something to be able to install it. So it's like, you want to think about it like an IKEA kit of parts, shipped to site, already prefabricated. The majority of the system's already prefabricated in-house. And then you're attaching what's called like a spacer frame directly on the glass using structural glazing materials that are already pre-applied. So you're peeling a tape, applying a primer, and then you put these using the guiding tools that we have. And then within the next few hours, it can receive the kind of new layer of glass with all of the other components, what we call it a unitized glazing panel. And it's locked into position using a very special kind of 3-axis movement. So there are no fasteners because we're not drilling through anything. and then we put a perimeter vapor seal around the unit, and then it's done. You have an insulating glass retrofit.
Interesting. Okay, very cool. Um, all right. Are there specific limitations currently with the technology around execution on how big these buildings can be, the height and everything like that? Any specific limitations? Like, does it have to be an inset window versus kind of flush to the surface? Anything like that?
Well, so mainly weight is the primary element that we look for that could become a limitation. And it depends on the size of the window, the building size and location, and a number of things that we do on the back end. We also have formulas that looks at the wind load, the dead load, and all of the other aspects of the curtain wall system or the window system. So, for example, certain areas or certain buildings, we cannot use a 6 mm glass like core, and so we go to 5 mm. In other areas where you have very high wind load requirements, so we need to sometimes customize the system for it, if at all. So right now, our system is adaptable to 98% of the buildings in the US. But for example, if you get a building on the coast of Florida where they require like 170 miles per hour or expect 170 mile per hour wind gusts, then we'll need, and you have like a high-rise building where the windows are really large, like 5 by 10, then part of our system needs to be customized for that. So I wouldn't say there are limitations. It's the standardization that we currently have is adaptable to 98%. So if you get a project within the 1 or 2%, then you need to customize a few things to be able to execute that.
Yeah. Okay. Interesting. And let's go a little bit more into the business building aspect. So you talked about getting a non-dilutive grant to begin your work. Can you just walk us through the process at the beginning there of, in particular, how you decided and when you decided, okay, now I'm going to go do this full time. I'm going to go put all my time and effort into building this technology. What was the timeline? And then let's just go through those stages of the funding.
Yeah. So it started with, like, for the first year, it was a part-time gig. I was doing my master's degree full-time in Boston, and at the same time I was working full-time. So I only had time, during the weekend basically to really work on this. And it didn't make sense to quit work and quit everything and just focus on it for the first year, because it's still an idea. There's a lot of uncertainties around it. So after that first year, it got to a point where the system conceptually and the technology conceptually is feasible. And that's where I thought I wanted to really devote all my time, and it's worth it. So what I did basically is I told my school that basically that's the topic I want to devote all my time for the master thesis for it. It's a bit too technical for a typical architectural master thesis, but the school was very supportive, and they said, whatever you want to do, we're supportive. So I quit my job and moved to Houston. So we have family in Houston. And we moved in with them for like a year to afford working on this for another year full time, basically while you're not making any income. So we cut expenses to almost nothing, and for that other year, that's where I made a lot of developments to get the system to be ready for fabrication. From that point, that's where I started, kind of going through the Clean Tech Open Accelerator, because I'm a first-time founder. I don't have real experience in kind of building companies and taking them from, a startup to an IPO or anything, or an exit. So I wanted to go through an accelerator. Plus, I'm a foreigner, coming to the country, no connections, potentially language barrier and things like that. So it was very hard to do everything on my own. So the accelerator was very, very critical and kind of advancing and giving some credibility that is much needed at the beginning, where the founder or the team are unknown basically in this world. So that's kind of the point where I quit my job and came here and started working on it. So
okay, so then you got that initial, once you went through the accelerator program, make sure I got this right. You went through the accelerator and there was a $50,000 grant. You're able to kind of go and then build the prototype. Then what? Then what happened? How did you go from there? Were you able to prove something out and then get more funding? How did that work?
Yeah, so at the same time, so the accelerator program was about like 6 months type program. It's like a mini MBA, but it's like a real life MBA. So you work on an actual idea, actual potential business. And one of the interesting things that they build a mentor team that is well suited for you or appropriate for you for the current stage. And these are folks that are either ex-CEOs that have done this before and can guide you, or investors, or executives that have been through and have done. I've seen companies grow and see how that is typically done in other areas. And one of the mentor team members was the board member for the Central Texas Engine Network. And so after 6 months of seeing how, of going through the program and the learnings and everything, so we built a really nice relationship. And he said, you should go through the C10 process. So I went through it kind of simultaneously. And that's where actually he wrote the first check. So he put the first 50,000. And then within a week, we got the award announcement and we got the second 50. And then other investors came in when we saw that, and we raised the first 250K. So that's 250K was then used to partner with the glazing. Basically, we've partnered with a glazing fabricator and a facade manufacturer here in Dallas, and we start working on fabricating the first version of the system, the first prototypes. And then we took that and we went to Intertech, which is one of the leading independent testing facilities here, and put the first prototype through tests. After that, so when the technology passed these tests, the investors doubled down on their investment. So there was like that component that you pass the test, we double down on the investment because it's like a major milestone. From that point, the next target was to do a pilot to install the system on an actual building, and that's alone is a very, very big challenge, because you're going to a building owner and say, hey, I want to try this new technology on your building for the first time. We haven't done anything like that before. So finding the first early adopter was a key component. That also happened through another accelerator program, and that was in Boston, the Greentown Labs. So Greentown Labs put out a competition, ended up being selected and winning. And it's interesting, they connect you with a strategic partner. And that strategic partner ended up being Saint-Gobain, which is one of the world's leading glass manufacturers and building product materials. So we went through the process and identified a pilot, and then we installed our system for the first time on their North America Research Center in Greater Boston area. And that got us the first customer, because the first customer was waiting to see the images and photos of the first installation to feel comfortable about it. And they said, I told them, give me 1 or 2 weeks and I'll send you images. And that was when, we were executing the first installation. And then they saw it, they liked what they saw, and they said, okay, we're willing to do a pilot with you. So we did a pilot, and that was in Seattle. The pilot worked really well, and within a few days, they decided to go out and upgrade all the single pane windows in that building in Seattle. So that was really our first actual customer, first actual project. And then, from one to another, so you can kind of see the milestones there.
Yeah, that's really fascinating. So I maybe just want to kind of walk that back and highlight a few of those things if I got this right, which is that you had this idea, you didn't have actually the technology built yet to prove it, but you had some people who were very interested in the space and saw the potential. One person wrote a check, and then you got an award, which then kind of snowballed, and you were able to raise 250. And then you ended up going into an accelerator program, which allowed you to find a strategic partner who would kind of take a shot on you, right? These people are forward thinkers, people who are interested in trying out new things without having to be coerced, essentially.
Yeah.
And then from there, once you had that proven and saw that, hey, this is how it actually looks, it's something tangible, then a real customer was able to buy, or was interested in buying.
Yeah.
So one thing I want to clarify is with that strategic partner, was this a situation where they actually also invested, or they just said, hey, you can use our building as a test site? Like, how does that work?
So they invested actually. So we were after that. So we raised another. We raised like 500,000 that they put in. So they invested twice so far in the company, and they now have a board, kind of a board observer seat on the board of directors. So it ended up being really a great partnership and relationship with them. And the idea is because you said it right. You're looking for an early adopter who is forward thinker and willing to take risk. And a lot of times, the very first one needs to have some sort of technical capabilities to understand the potential, like what's the extent of the risk here. So this was not a traditional commercial building owner. It was like a research center. You have all of the very smart people there in North America that are actually developing technologies and systems, and glass is one of their specialty. So it was much easier for them to understand the technology and kind of understand the potential risk in it, and take a leap of faith on us. And throughout that, for example, they helped us, their director of R&D, they helped us go through an FMEA, like failure mode and effects analysis study on the installation to foolproof that. So that was very helpful. And then they also invested in the company because they have a venture arm. And if you look at it, it was a very, very, critical and helpful point in the history line of this company, INOVUES. So you got funding, you got a first pilot customer, and they covered the cost of the pilot too. And it was they helped you improve the technology too. So that's what more than that can a founder hope for. So it was a very, very helpful relationship.
Yeah, I mean, it seems quite interesting. It's really encouraging to see I guess the ecosystem is working and making things work, because obviously it is difficult if you have different mentality people, right? You mentioned it's an R&D lab. These people are trying to think about big problems. They may be in many cases less kind of commercially focused, whereas a building owner operator is going to see, hey, if I do this is going to be an expense, but I need to prove, like, I got to have complete proof that it's actually going to benefit the energy efficiency targets or whatnot. So you need to have that proof. It's just interesting. Maybe something worth noting to the audience is that if you're doing a technology like this, it seems as though the secret to it is finding the person or organization that has a perfect alignment. And there's most likely somebody out there, right?
Absolutely.
One thing I'm curious about is the IP process. So I'm sure there's some types of things here that are IP. You have your own intellectual property that you need to protect. What have you learned through this a process about making sure you get patents in place and everything? I've never really asked this question to guests, so I'd be keen to know a little bit about that process, what you learned from that, and what you would have done differently.
Yeah, I mean, that was a very important point throughout, from the early days. And I can't stress this enough, how, for founders, because at the beginning, you're a lot of times you're bootstrapping. And this world of intellectual property and patents is like a black box. So, and it's very expensive, could be very, very expensive to get a patent, go through that route, and it takes a long time. So one of the first things that I tried to do, like for that first year when I was like here in Houston working on the master thesis, is to learn about patent law in my free time, if there is any free time. So for the first year, it was just, reading a lot about, the patent application process, how patents work, how patents are written, and what's actually patented, the claims and the description and the prior art and all of these kind of things. So that at least when I'm talking to a patent attorney, I know what I'm talking about. And then you're able to select a really good patent attorney. And then at the beginning, you're not going to be able to have a patent, an IP attorney or a team of attorneys draft that for you. This could run, tens of thousands, even hundreds of thousands of dollars. So most likely you're going to be the founder or the CTO or the technical person who needs to draft the majority of the specs, specifications. So that's how I went about this. So we learned a lot, found a good patent attorney that specialized in the space, and ended up working with him to be able to put together the first what they call provisional patent application. This gives you, once you file, you need to make sure that you're not publicly disclosing anything that is considered IP before you file. Otherwise, it'll act against you as a public record or public knowledge. So for example, before submitting my master thesis, I filed this provisional patent application with the United States Patent Office, and that gives you an early date. So it gives you what's called a priority date, and from that date you have a year, and within that year you can then file a full-blown patent application. Could be like 20, 40, 60 pages. With all kinds of details and manufacturability and all of that. And because, at the beginning, when you're developing the technology, you might not know 100% about how this thing going to be built, but you want to get some protection of the aspects that have been developed so far. So a lot of times you file a provisional, and then you develop something else, you file another provisional, and try to create these kind of series of provisionals to get you protected. And once within that first year, before the year lapses, you file your final patent application. And then you have, depending on the process, for us, we had a very good patent attorney where, you need to have a strategy, an IP strategy, and how you're going to the patent office, because you want to increase your chances of getting a patent. So if your claims, what you're claiming is really, really wide, there's a high chance of it being rejected, and you need to go back to reiterating and narrowing down the scope of what you're trying to claim as patentable. So there was a lot of work on that area too, and that's how we got the first patent, and then we continued with that process, and now we have about eight or nine approved, kind of issued patents and pending patent applications in the U.S., Canada, Europe, and China.
Interesting. So that's quite fascinating. It sounds kind of interesting to me that if somebody, you mentioned that you didn't put your thesis out until after you had filed what'd you call it? Provisional
patent application.
Provisional patent application. But if you had, would it have basically tanked the whole thing, or just been probably negative?
It could tank the entire thing, because it's a public record that this information, this proprietary information, already exists in the public domain, and anyone can access it. Before you came and say, hey, I have this idea, or I have this technology that is patentable.
It just seems interesting to me that, because obviously how many students are probably coming up with actually relatively interesting things who may not necessarily even intend to build a business out of it, or maybe you could speak to this. Is there an infrastructure inside of the universities to help basically talk to the students and say, hey, by the way, like the professor might be like, this is pretty cool. Let's get you through this process to do, file that provisional. Is there anything like that?
In I would say most cases there is. The only different part about architectural schools and university, colleges, is that unfortunately it's less familiar for an architect to come up with an invention. So it's not like when you, for example, go to MIT and in the engineering department, or even the architectural department, they have all that process figured out from all other specialties and schools and disciplines. So they know exactly what to do, and they have a patent office inside the school. In my case, it was not that. So just because architects typically they are very creative. They are solving a lot of things, and a lot of times these could be inventions for systems that could be scalable, but it's limited to one project. So it's very, very custom bespoke solution to a single project. So but I would say, yeah, a lot of schools and universities have that kind of patent office and technology transfer office where they can guide you and can help you about in the first steps of the process of what you need to do, and
Mhm.
you can go around that. And
Do-
sometimes they cover the entire cost, but they own the IP at the same time. So there's a kind of a little bit
Yeah,
behind
yeah,
that.
I heard about this recently. Somebody was speaking about, I forget which podcast I heard it on, but they were talking about this IP transfer and how a lot of the schools are trying to capture it, even if somebody else, in their research lab came up with it, they're getting no ownership of it, right? They're not getting even in some cases any ownership of that IP. I think it'll be interesting to see if there's more equitable models for that. But again, it doesn't make sense that some of these resources wouldn't have been afforded to these people, but anyways, it's a topic for another time. One
Yeah,
thing I'm kind of curious about, so I'd like to continue down the funding path here. So once you once you got your first customer kind of things started rolling, was this something that you built the model so that you could bootstrap it, or did you then decide, okay, we're going to go raise again? Because if I'm not mistaken, this is largely a hardware technology. Yep.
yes.
So it's a hardware thing in climate tech. Hardware and climate tech are difficult. Not a lot of funding partners, especially if you look at when did you begin? This was 2018 or so when you were
Yeah,
really getting going.
yeah, exactly.
So I guess there was some climate tech infrastructure there, but what happened after that? After that original 250,000, you've got now a new customer, and I'm assuming maybe a few more. Walk us through the next steps in that funding process.
Yeah, and as you said, hardware and hard tech is hard, and a lot of the investors prefer to invest in software companies and SaaS models and things like that, just because they believe that with hardware you have a very capital intensive business, and manufacturing facilities, and you need a lot of investment to go into equipments and R&D and fabrication, manufacturing, and all of the infrastructure that goes there. So knowing what I knew, that's going to be a very strong uphill battle to do at the beginning for a first-time founder, a technology that is, there's a lot of things at the beginning that people didn't believe that this could work, because the way we're putting the system on is basically using adhesive materials. And if you think about it, just adhesive for people that are outside the industry, that's they start to feel or think or imagine like Scotch tape and things like that, and it's like start feeling that Windows going to fall out and all of this potential risk. So a lot of people did not believe that this could actually happen. So I had to adopt a capital efficient business model and say, hey, we can raise like 10 million from the get go, even when we had our first paying customer or early adopter, and we need to adopt like a milestone based funding strategy where you achieve, you build the first prototype, you raise 100K, you pass the testing, you secure the 250, get the first pilot, you do the 500,000, get the first customer, you go for a seed round. And this way, you're kind of de-risking the technology as you go through, and you're raising the least amount of capital you need to be able to get you to the next level or to the next point. So in that process, we didn't say that we need to build our own facility from scratch and from the early days and hire our own people in every position to execute this. We said we're going to rely on existing partners, existing infrastructure, and existing resources, and build something that can be really scalable fast, where you don't have any capital intensive components to the business. So manufacturing, fabrication, and installation for us is outsourced right now, and we're acting more like a technology company. So we're very nimble, and basically our burn rate is to the minimum, and just personnel and engineers that are working on this. And for example, when COVID hit, we didn't really worry about having a facility that is going to now be a liability, and you need to think about costs and expenses or labor or people that you need to lay off because there are no work, for example, or anything like that. So that was very, very helpful to use or to do basically from the beginning.
Mm-hmm. Okay,
Yeah.
so then after, did you raise another round beyond that initial 250 then?
Yeah, so we did a 500K convertible note as well, and then we did a 2 million seed round. That was our first equity round. We closed it at the end of 2021, and that got us to where we are now. Kind of validating a number of other stuff. So you're always validating new things. Go-to-market strategy,
Yeah.
scalable, getting more clients, and testing, improving the product, continuing to do R&D, developing new solutions and new use cases. All right, now we're looking to raise a new round, like a Series A, where now we're thinking about starting to vertically integrate part of the process, part of the fabrication process, which would be beneficial on a number of aspects.
Got it. Okay, interesting. So one thing I'm curious about is the partnership. So you mentioned that you're essentially trying to build a platform for these other technologies. How do you work with that? Is that, you have to come up with some very elaborate partnership agreement at the beginning? Are you going to be able to get a kind of a percentage of the proceeds of their sales and vice versa? Will they sell your technology in order to implement their technology? What does that look like?
Yeah, I mean, so that's a number of partnership types. So we have fabrication partnerships that are different than installer partnerships, different than referral partners or sales partners, and that's different than glass technology development partners. So I'll start with the last one. Basically, you get a joint development agreement in place where you're saying we're going to develop this combined system that has your glass technology with our retrofit system that could be available to the market, and basically we'll share the benefits of that, or the financial outcome, or financial profit from that development when we sell. So the technology ends up becoming owned by the two parties, the newly developed IP. The foreground IP or the previous IP is owned by each company, and then where you're trying to license, or one company is selling this, they'll both share basically the revenue from it, or they will figure out a way to kind of have a revenue sharing component to the agreement. So that's the joint development agreement. At the same time, you're looking at fabrication partners. So fabrication partners. We had a pilot fabrication agreement where we said, hey, we're looking to, we don't know all the details. So for example, you're going to fabricate units for us. We don't know how long the units are going to take, and we're still iterating, and we don't know how much labor intensive that process is going to be at scale. So you start with a pilot fabrication agreement and say, hey, let's do a few units, and based on that, estimate what that can look like in terms of time and efforts and resources, and have something for the first year or first 2 years with a little bit of terms around fabrication and small quantities of products fabricated. Once you go through that, and they now learn more about what's needed from their side to be able to produce this, what's needed from our side to know about cost and efficiencies and things like that, and then you can have a full kind of fabrication partnership agreement where you have all the terms conditions around that. Same thing with installers. Now, referral partners or sales partners, these will be paid in commissions, and then you'll need to say, okay, you're gonna become a representative of our company and of our technology in this region. And what are the terms around that? If you bring us a client, what type of percentages you're going to get in return? What are the expectations? The length of this agreement? So that's a sales partnership agreement. So and you need to work with attorneys, of course, to have all of these agreements put together, and you make sure all the terms are covered and everything is kind of put together in these documents.
Okay,
but a lot of times, one important thing to mention, especially to founders, is that a lot of times this happen not at the beginning, like not at the first initial steps of the relationship. You first, a lot of times what we do, there's nothing in writing, maybe sometimes an NDA only. Once you're starting to talk about what the potential outcome could be, or what's the potential collaboration could be, sometimes you go through doing prototypes and really working for a kind of a long period of time, sometimes a year, before having any sort of partnership agreement put together. And that's fine, because it's time consuming, especially if you're talking about two startups working together and they already have finite amount of resources and very little time on their hand. They're working on developing their product, and now they're going to integrate other technology into it. So having minimal paperwork at the beginning is okay, and then as you kind of develop this relationship, you'll feel when the time is ready to start to put together an agreement with all the terms and conditions and everything to it. You can start with a term sheet first, agree on things, and then you sign it, and then you can sign the final agreement later down the road when you're ready.
Yeah, because eventually you're gonna have to pay lawyers to come up with a lot of that stuff, and it's not a cheap endeavor.
Yes,
Interesting.
exactly.
Okay, so maybe I know we're running out of time here, but there's one last thing I do think is important to cover, which is the financing of these projects. So is this a pure play model where the building owner pays for this technology to be installed? Do you have a model where you take a baseline of what efficiencies they have, and then um you'll just take a certain percentage of their profits that they're saving? Like how does the financial model work for this?
That's a great point. So typically when we go to a customer, we offer them a number of financing options. So they can pay for it upfront, like in cash. They can finance it on their own. And there are a number of easy financing options available now, like PACE or C-PACE, commercial PACE, for example, where they get a loan and the loan is tied to the asset or the property, not to the building owner per se. And you get a 20-year term with very low interest rates, and you can fund the energy retrofits out of that. Or we can help them. So we can finance the technology, and they pay us over a course of 5 to 10 years, for example. So they're not paying anything upfront. So zero upfront cost for them, and they start to reap the benefits from day one, the energy savings. There's a new model that we're trying also to develop, similar to the solar model, where you're saying, you get to pay. So even in the easy financing options we're offering now, they're getting a loan, but we're facilitating that loan, but still the owner that is actually carrying the liability of the loan. So there's another model where you're saying, we're going to put money in your pocket from day one, and you're going to pay us for the next 20 years, for example, and we'll cover everything related to those facades or window upgrades. And it's not the building owner that is getting a loan, it's us. So we're getting the loan, we're financing this, and it makes it much easier for customers to acquire a certain upgrade or acquire certain technology, instead of having, especially in the current environment, think about high interest rates and ability to secure a loan, or if they need to leave that for something else to do for other types of upgrades or investment in the building or the asset. And here is a different mechanism where it's based on the energy savings purely.
Mm-hmm.
And you kind of look at, you build an energy model, and you see how much they're consuming today, and you're really within a very small margin of error. You can estimate what are the savings, and then you can tell them, hey, here's the gap, and we're gonna provide this technology where you kind of share some of the savings, and we get some of the savings to fund
Mm-hmm.
this.
Yeah,
Right.
no, that's great. I mean, I think that's really fascinating. It's obviously important to find the most frictionless
Yeah.
method of getting this technology installed. So this is really good. I mean, obviously there's some other things I would like to have asked about, but I think we're out of time here. Any final thoughts for the audience? Things that, what is your ask to the audience? Final thoughts on the future of this technology and the green prop tech space in general?
Um, you know, if any founder is trying to get into the climate tech, or is in hard tech and would like to bounce some ideas, or need any help with anything, I mean, please feel free to reach out. I mean, my email is Anas, ANAS, @inovues.com, and would be more than happy to help if at all possible. And I would encourage any founder, especially in these kind of hard tech spaces, to find an accelerator that that is relevant to their industry, where they can either connect with a strategic partner in the space or have some focused experience or model around what they're doing, because it can be really, really helpful, especially for first founders.
Yeah, it sounds like if it wasn't for that network and ecosystem, it would have been a much more difficult journey. But
Almost
all,
impossible.
all right, Anas, I really appreciate you coming on. It's been great to have you, and
Thank you.
looking forward to seeing what you guys continue to do.
Thank you so much for your support. Appreciate it.